The physical layer. The physical layer deals with stuff that you can touch. For example, cables, hubs, and repeaters. These are the three things that work specifically at the physical layer. Now, sometimes in classes I get a question, and some people ask, well, Junaid, you said that the physical layer deals with devices that you can touch. I can touch a router. Now, when we get to layer 3, I will tell you at that time that routers work at the network layer or layer 3. And you can touch a router, so why does it not work at the physical layer? The answer is, when I say a router works at the network layer, I mean it works at the network layer and all layers below. When a device works at the physical layer, there's nothing below that layer. It only works at the physical layer. A router, for example, again, will work at the network layer, the data link layer, and the physical layer. The 3 device types that work only at the physical layer, number 1 would be cabling, your cabling. Number 2 would be your repeaters. And number 3 would be your hubs. Now, covering cable types. The first cable type is your X-base-T cabling. Everybody commonly know this as your Ethernet cabling. The X in the X-base-T stands for the speed of the cable. The word base stands for baseband signaling, and the letter T stands for twisted pair. Now, let's look at X. If that first X in X-base-T is the number 10, that means the cable can transmit at 10 megabits per second. If that number is 100, it can transmit at 100 megabits per second, and if it is 1,000, that means the cable can transmit at 1,000 megabits per second, also called a gigabit. Now, the base in the X-base-T stands for baseband signaling. Baseband signaling means that there can only be one signal on the wire at a time, as opposed to the opposite of that, you guys all have it at home, is called broadband signaling, where you have more than one signal. I assume you have more than one channel at home, and your cable also carries your internet. So you can have more than one signal on the wire at one time. The T in X-base-T stands for twisted pair. That simply means that 8 wires or 4 pairs of wires have been twisted together to form that cable. Now, for those of you that are wondering why sometimes when you go to Best Buy, you can buy a Category 4 cable or a Category 5 cable or a Category 3 cable. That's simply Category 3, Category 4, Category 5 differ simply in the fact that Category 5 has more twists per meter of wire than a Category 3. And more twists means you have more copper. More copper means a cleaner signal. That's the only difference. Now, X-base-T cabling come in 2 flavors. They can either be straight through or they can be crossover. For the purposes of CCNA, all you need to remember is like device types or similar device types will use a crossover cable between them. Unlike device types or 2 different device types will use a straight through cable between them. So an end host like a computer and a switch will use a straight through cable. If you have a connection between a router and a switch, you will also use a straight through cable. If you're connecting 2 switches together, you're going to have a crossover cable. If you're connecting 2 routers together on their Ethernet ports, again, you're going to have a crossover cable. The last connection type is your connection between a PC Ethernet and a router Ethernet. That will use a crossover cable also. Moving on. X-base-T cables there are 2 types of X-base-T cables. One is your shielded twisted pair, and the other one is your unshielded twisted pair. The unshielded twisted pair are the ones that you are familiar with, that you use at home for your Ethernet connections. The shielded twisted pair is only used in places where there might be electromagnetic interference. Now, every device that runs an electric current through them, like a refrigerator or an air conditioning unit, produces an electromagnetic field. If you run a regular cable or an unshielded twisted pair cable behind that device, behind a refrigerator or an air conditioning unit, you might have signal degradation. So the signal might not be clean and pure. To prevent against that, They are cables made with a special shielding around them, and when you run a cable behind a device that produces an electromagnetic field, you run a shielded twisted pair cable. The other cable types that you need to remember are your serial cable or the V.35 cable. The serial cable is connected to a serial port on a router. So between a router and another router, you will run a serial cable. The last cable type that I'm going to cover are your rollover cables or your console cables. So from the console port of a Cisco device, which is located in the rear of the device, and it actually says console, to the COM port or the communications port of your PC, you will run a rollover cable. This cable is actually the cable that enables you to directly connect to a router. So you would run a console cable from the console port of a router to the COM port of your PC, and then you will open up a terminal emulation program, such as TerraTerm or PuTTY, and then as soon as you open up that program and you power on the device, immediately you will see that you're on console, that you're logged into the router or the PC. That concludes the cable types that we're supposed to cover for CCNA. The next device that I'm going to cover that works only at the physical layer is your repeater. So a very rudimentary diagram of a repeater. Let's say this box is a repeater. Now, a repeater does exactly what the name says it does. An X-base-T cable is capable of carrying a signal for a total of 100 meters. After 100 meters, no guarantees are made that the signal will not degrade. So what a repeater does is if a signal is coming inbound on a cable this way, it will repeat it out and amplify it for another 100 meters. Usually, if repeaters are being used in a network, the network wasn't properly designed, or at least that's my opinion. Now, what is a hub? A hub is nothing more than a multi-port repeater. If we change the name of this device over from a repeater to a hub, and we go ahead and connect 3 PCs to it, or 4 PCs to it, these little boxes represent PCs, and let's say this is PC1, PC2, PC3, and PC4, and PC1 sends a transmission. The hub will flood the signal out every other port to all other devices except the port that originated the signal. So it makes sense. PC1 sent the signal. You don't want PC1 receiving the same signal back. So a hub will repeat the signal out or flood the signal out all other ports except the one that originated the signal. Remember that, because on the CCNA exam there is a question, what does a hub do? And the first answer that you will see, it will say a hub floods out a signal received on one port out of all other ports. And if you pick that answer and move on, you probably got the question wrong. Because answer F might say, a hub takes a signal in one port and floods it out all other ports except the one that originated the signal. You just got that question wrong because you didn't read far enough. And answer F is more correct than just saying a hub takes a signal in one port and floods it out all other ports. You need those words except the port that originated the signal. At this point, we have concluded our physical layer for the CCNA. The CCNA physical layer questions aren't very extensive. They're pretty simple. For the most part, you might get asked what a hub does. And as long as you remember that a hub takes a signal in one port, and I know I'm repeating myself, and that's for a reason, a hub takes a signal in one port, repeats it out of all of the ports except the port that originated the signal. As long as you remember that, you will nail the physical layer stuff on your CCNA exam.